what I'm saying concerning the midpoint. If point P divide line AB into equal parts, the ratio M turn to X and ratio N turn to X. Now, when I go into this formula that I have here, the midpoint that I'm going to have now is going to be XB plus XA divided by the M and X are summed to X. So I have X plus X. So I can factorize this X out. So I can rewrite this one as A plus B divided by 2x. Since x cancel x, the midpoint now for the vector, for this division vector, is going to be A plus B divided by 2. That is in case 1, when P divides A and B equally. But case 2 is when point P divides line segment AB externally. There are two cases of external division: when point P is close to A and when point P is close to B. Let's start for this external division when point P is close to A. Look at what I did. Anytime I'm putting my points in the ratio, I normally put my ratio in order. I always move from A to P, then from P to B. As I'm moving from A to P, the value here is M. As I move from P to B, the value is N. Now, if I want to move from A to P, because like I said, my movement should pass through B, I have to go from A to P, then from P to B. If I'm going from A to P, in this case, my M will be negative. Why? Because I'm moving in the negative direction of the x-axis. So my M will be negative. Now, from P now, if I now want to get to A, to B, I'm going to have N. So my N will be positive. Now, if you remember, the ratio R is usually M divided by N. Now, in this case, my M is negative. So I have minus M divided by plus N. So this gives us a negative ratio. Negative ratio in the sense that minus divided by plus is negative. Now, if you look at this ratio, the M in this diagram is shorter than the N that is below. So I'm having something like, example, I may have something like minus 1 over 5. So in this case now, this one will give you something like minus 0. Let me say 0.2. If you look at the external, number line, if I have 0 and I have minus 1 here, then minus 0.2 should be somewhere in between 0.2. So somewhere in between minus 1 and 0. So that means if my ratio falls between minus 1 and 0, then the division point P is said to be close to point A. That's case 1. Now, let me call this case 1A. Then another case of external division is when point P is located close to B. This is my point P and this is my point A. Like I said the other time here, anytime I'm moving from A to B, I must pass through P and cover M. Now here I want to get to B. I must also go to P first. And then the ratio of A to P in the original, I have to cover distance M. So because I'm moving in the positive direction of the x-axis, this one will be plus M. Now from P to get to B, I'm moving in the negative side of the x-axis. Since I'm moving in the negative side of the x-axis, this one will give me minus N. Now from the ratio, which is M divided by N, in this case, the N is negative and the M is positive. Now in this case, if you look at this figure here, M is bigger than N. So like I'm having something like, let's say 4 divided by minus 2. You know that 4 divided by minus 2 is minus 2. And then minus 2 is more than minus 1. So minus 2 is more than minus 1. So that means I can have any other number apart from minus 1 to infinity. So what am I trying to say in essence is that when the ratio falls between infinity and ratio and minus 1, then point P is said to be closer to point B than point A. Thank you so much for your time in listening to my video. Please do not forget to share, like, comment, subscribe, click on notification button for more video. The video today is the getting an expression for the position vector of P that divide a line AB on a straight line into ratio mn, and generally that position vector of point P is given as m times position vector of point B plus n times position vector of point A divided by the sum of the ratio of division. Thank you so much. Have a nice day. Bye.